This is Rose C. Tantingco, base MT2, and for today's video I am going to explain the flow of urine through the nephron and ureters. Next is the structure of how urine flow through the nephron and ureters. So this one. So waste ions and hydrogen ions secreted from the blood complete the formation of urine. So, sa akong gipakita ganina nga structure, makita dito where the secretion happens. So, first is the filtrate absorbed in the glomerulus flows through the renal tubule where nutrients and water are reabsorbed into capillaries. At the same time, waste ions and hydrogen ions pass from the capillaries into the renal tubule. This is what we call secretion. The secreted ions combine with the remaining filtrate and become urine. The urine flows out of the nephron tubule into a collecting duct. It passes out the kidney through the renal pelvis into the ureter and down to the bladder. Next is hydrostatic pressure. From filtrate average 10 mm of mercury in the Bowman's capsule and drops to nearly 0 mm of mercury in the renal pelvis. This pressure gradient forces the filtrate to flow the Bowman's capsule through the renal tubule into the renal pelvis. Next is the peristaltic waves or pressure. It progresses from the region of the renal pelvis to the urinary bladder. They occur from once every few seconds to once every 2 to 3 minutes. It is because the hydrostatic pressure is 0 mm of mercury in the renal pelvis, meaning no pressure gradient exists to force urine to flow through the ureters to the urinary bladder. However, the circular smooth muscle in the walls of the ureters undergoes peristaltic waves of constructions which force urine through the ureters. Next is parasympathetic stimulation. Parasympathetic stimulation, it is responsible for stimulation of rest and digest or feed and breathe activities that occur when the body is at rest. While sympathetic stimulation, it is where the nervous system directs the body's rapid involuntary response to dangerous or stressful situations. The peristaltic constructions of each ureter proceed at a velocity of approximately 3 cm and can generate pressures in excess of 5 mm of mercury. Where the ureters penetrate the urinary bladder, they run obliquely through the pterygon. Pressure inside the urinary bladder compresses the part of the ureter to prevent urine from backing up into the ureters. So when no urine is present in the urinary bladder, internal pressure is about 0 mm of mercury. And even when the urine volume is 100 ml, pressure rises to only 10 mm of mercury. Pressure continues to rise slowly as volume increases to approximately 300 ml, but above volumes of 400 ml, the pressure rises rapidly. As you can see, urine flows through the nephron and ureters during the urine production. The pressures in the renal tubule decreases as the filtrate moves along it. To sum up, hydrostatic pressure forces urine through the nephron and peristaltic or peristalsis pressure moves urine through the uterus. That would be all. Thank you.